Warm welcome to one and all present here. This is Sriram R, and my research focus on dropout mechanisms for improvement in performance of active learning algorithms. So, going on to the work. So, the basic premise behind active learning is that machine ML algorithms can achieve data accuracies with lesser labeled instances if they can choose the data points from which they learn. So, however, in many cases, uh, like prediction on the approval of credit card of an applicant, prediction on whether a patient's uh, risk level is high or low, the annotator who provides the labels happens to be a human. So and these labels provided could be a result of human heuristics and biases which are inherent in them. One of the factors that introduce such biases is the tendency of a human to make decisions based on specific set of attribute values alone, rather than looking at all the attributes. This study aims to reduce such biases by proposing novel dropout mechanisms that can be coupled with the existing AL algorithms. So in order to mimic the functionality of an oracle, the human decision strategies from the published works of Poshkopolos, Serelskis, and Professor Gertz were taken, like the Franken's rule, good features, and mixed decision strategies. So these are the active learning algorithms which are also shortlisted for the work. And the predictions tasks which are shortlisted were all binary classification tasks. So the dropout mechanism A, as mentioned here, can be explained as follows. Say we have a prediction. Say we have a prediction task of 4 attributes as such. So now all the combinations of the subset of attribute values are considered. So for each instance, a subset of attributes are randomly chosen and sent to the HTS. Now, this HTS provides the labels for that particular instance, and the labels provided along with all the attribute values are used to train the active learning algorithms. We do this so that if a human is biased towards a particular attribute, there would be instances where he would be forced to provide labels without info on that particular attribute. So unbiased labels could be obtained for such instances. We also obtain graphs by measuring the performance of AL algorithms with respect to number of attributes dropped, and the following are the findings. So the mechanism did improve the performance in majority of the cases when only a single decision strategy was used against mixed strategies. This is because there is already an inherent variation in prediction when a mixed strategy is used against a single decision strategy. The mechanism also impacted well when the number of attributes was less. This is because the proportion of biased attributes dropped will be more when the number of attribute values are less compared to the cases where the number of attributes were. And this is a caveat for this particular dropout mechanism A. So when going into dropout mechanism B, here the idea is to drop attributes that have high correlation, which is beyond a particular threshold, with the target variable of the previously labeled instances. The idea is that the annotator could have been biased his responses on this particular subset of variables as such. So looking into, we also obtained similar graphs similar to dropout mechanism A, but here we varied the threshold value rather than the number of attributes dropped. And the scenarios where it showed improvement in performance were significantly more when compared to dropout mechanism A. Like look into good features, and around 87-88% was really useful in improving the performance. And similar to previous case, the trend was followed for mixed decision strategy. It was not that useful compared to only single decision strategy was used. And however, one significant caveat where when the number of attributes are more, the dropout mechanism was not that useful. A was not that useful, but this is, this has forfeited that where like when you consider biodegradable, when the attributes are very large, around 72% of the cases, this was really useful, showing an increasing performance of around 3 to 4%. So, and it's also so happened that the threshold was around, should be around 0.4 to 0.6 in order to obtain the peak performance. And similarly, in mechanism A also, the number of attributes to be dropped should be around, say, 40 to 60% in order to obtain the peak performance. So thus we looked into how the two novel dropout mechanisms has impacted towards the AL algorithms. We looked into variety of scenarios where it did impact well and scenarios where it did not also impact well. And I mean, that's all from my side, and would be glad to take up questions. So thank you for the opportunity.